Hello again, everyone. This is Mr. V. Hill, and today I'll be talking about solving absolute value equations. And so, since solving, of course, means to undo what's being done to a variable, we need to know how to undo this absolute value function. And so, if we just look at a really simple example, if we're taking the absolute value of 5, of course, that's just 5. Because the absolute value just gets rid of negative signs, but since there's no negative sign on the 5, it's just 5. And of course the absolute value of negative 5 is also 5, since we're talking about the distance a point is away from 0 on the number line. And we could model this activity here, or this function, with one of these mapping diagrams. This is one of those cases where this is actually kind of useful. And so if we want to model this, we can take the absolute value of these items in the domain, and we'll get this item in the range. And we can just show that 5 is going to be mapped to 5 with an arrow like that, but also negative 5 is going to be sent to 5 as well. So we have these two arrows coming into 5, coming out of both 5 and negative 5. And so if we want to look at how to undo this action, we just have to take the arrows and go back the other direction. And so if we do that, we'll put, of course, 5 and negative 5 over here. It's going to look a little bit obvious for a moment, but it's a bit more than just arrows. So the inverse operation for the absolute value would take 5 and send it to 5. But it would also send 5 over to negative 5, because both of these arrows would be going back the other direction. So this inverse relation is not a function, since 5 is going to be going to both 5 and negative 5. But if we want to give this thing a name, what we could do, well, see, 5 is sent to both the positive and negative version of itself. So these arrows going back the other way, if we wanted to give that relation a name, we might call it plus and minus. And I'm sure you've seen this symbol before, a little plus or minus kind of thing. It just means that we're going to take both the positive version of the thing and the negative version of the thing. So 5 gets sent to both positive 5 and to negative 5. So if we had an equation, say the absolute value of x is equal to 5, the way we would solve this, meaning we would undo what's being done to x, to undo these absolute value bars, we just need to put a plus or minus on this side and a plus or minus on this side, because we have to do the same thing to both sides. And the idea here is that this plus or minus operation or relation is going to cancel out those absolute value bars. So our equation now becomes just x on the left-hand side, and that's equal to plus or minus 5 on the right-hand side. Now what this really means is that we actually have two different equations going on. One equation in which x is equal to positive 5, and a second equation where x is equal to negative 5. So we have two solutions. And this is where the set notation comes in a bit more than in previous examples, when we have more than one solution. So we say that the solution set is equal to the set of both 5 and negative 5. And whenever we're solving equations, of course, we want to check by plugging these back into the original equation. We plug 5 back in for x, and we say, is the absolute value of 5 equal to 5? Well, of course it is. And we plug negative 5 in as well, and we ask ourselves, is the absolute value of negative 5 equal to 5? And of course it is. So this is our correct solution set. Okay. Well, let's apply this in a little bit bigger example, though, like this one here. So now we've got a lot of stuff going on over on this left-hand side of the equation. We've got some multiplication, a subtraction, then the absolute value, and then some more multiplication and now an addition. And this is where this table might come in handy for you, just to keep things straight. So first, let's list all the things that are being done to x under this operations column. And we'll put the inverse operations over here on the right-hand side. So, first thing we have is multiplying by 3. And the way to undo multiplying by 3 is, of course, to divide by 3. Then we have a subtracting 8. The opposite of that is adding 8. Then we have these absolute value bars. So I'm going to write that as ABS, just abbreviation for absolute value. Just because if I put absolute value bars in there, it'll look like an 11, and well, what the heck is that? You might get confused. But the way you undo taking the absolute value of something is this little plus or minus. I'm going to take the positive version and the negative version of it. Now after we take the absolute value, then we multiply by negative 2. Of course, we undo that by dividing by negative 2. And finally, we're adding 4. You undo that by subtracting 4. And so we're going to solve this equation, meaning undo what's being done to x, by applying these inverse operations to both sides of the equal sign in reverse order. So, starting down here, first thing we're going to do is just subtract 4 from both sides. Of course, this adding 4 and subtracting 4 are going to cancel each other out. And we'll rewrite the whole equation. So negative 2 times the absolute value of 3x minus 8 is now equal to negative 8 minus 4 would be negative 12. Okay, we've taken care of this guy. Now we need to do this thing and divide both sides by negative 2. Of course, that means that those two factors are going to cancel each other out. So we're left with the absolute value of 3x minus 8 is equal to negative 12 divided by negative 2 is positive 6. Now, we've done these two things. Now we need to apply this plus or minus operation. So we'll take plus or minus the left-hand side and also plus or minus the right-hand side. And what happens here is that this plus or minus is going to cancel out our absolute value bars, because this is the inverse operation of the absolute value. So we're left with 3x minus 8 on the left with no absolute value in it, and that's now equal to plus or minus 6. But what this actually means is that we have two equations now. The whole thing splits. So one equation is using the positive version of 6, and the other equation is using the negative version of 6. So we have 3x minus 8 is equal to 6, or 3x minus 8 is equal to negative 6. You might even put in a big or there, just to show that either situation is okay. Now we've undone these three things down here. Now we need to keep going and keep undoing what's being done to x. But we know how to deal with either of these two equations, and luckily enough, the exact same things will work to undo what's being done to x in both of them. So, first we will add 8 to both sides of this equation, and we will also add 8 to both sides of this equation. So of course, these will cancel like that. And we're going to be left with 3x is equal to 14 over here, or with this right-hand equation, 3x is equal to negative 6 plus 8 is 2. Now again, we just keep on undoing what's being done to x. We need to apply this dividing by 3 to both sides of each of these equations. Those will cancel, as will those. And now we get that x is equal to 14/3, or x is equal to 2/3. And now we might want to put our solutions into a set to show that they're, well, it's kind of silly to use this notation, but still, the solution set is now consisting of both 14/3 and 2/3. But of course, we want to check these solutions by plugging them back into the original equation way up here. And I'm just going to do it with a calculator really quick to show you that that's not too hard to do, and also to show you where the absolute value is on the calculator. So we're going to plug 14/3 into this equation. So we've got -2 times. Now to get to the absolute value, we're going to use this math button here. I'm not sure if you can see it on the screen, but there you go. The button that says math right there. Hit that and we're at the math menu. Now go over to NUM for number operations. We see that ABS, there's our absolute value. So you can either just hit enter now or type the number 1, and that brings up some absolute value bars. And now I just type in the rest here. So it's -2 times the absolute value of 3 times 14/3 minus 8. Now we need to click to the right to get out of our absolute value bars. And now we still got a +4 out there. Hit enter, and we see that that's equal to -8, which is exactly what we wanted it to be equal to. But that's just checking the one solution. We also have to check the other solution of 2/3. I can do that by it's a little bit simpler if we just bring up what I typed in last and edit this 14/3 in here. So you see entry on the enter button. If I hit second and then hit enter, it brings up the last thing that I typed in. Now if I just scroll over here, I'll delete the 1 and I'll overwrite the 4 with a 2. And we see now that I've got -2 times the absolute value of 3 times 2/3 minus 8 plus 4. That's what I get when I just plug in 2/3 here for x. And I should get a -8 out when I hit enter, and sure enough, yes I do. So both of our answers are solutions to this original equation. And this getting more than one solution out, that's going to come back to us again when we start undoing squaring and things like that. So this is going to happen some more when we start solving quadratic equations, this splitting into 2. Anyways, that's a pretty simple example, and now I'm going to leave you with a couple of practice problems. So go ahead and work through these, and if you have any questions, feel free to leave them in the comments section below, and I'll see you all in class.